Hi, this video is going to be covering solving systems of equations using elimination when you have to multiply both equations in order to get an addition or subtraction problem so that you can solve. Hopefully you watched my first video, the one I uploaded before this, so you can see how you can scale up one of the equations in a system to make it a viable addition or subtraction. This video is going to be covering when we have to scale up both equations. Here is an example problem for us. So looking here, I want to figure out what variables I can either add or subtract. So I can't add the x's together, I can't add the y's together, neither of them will cancel to get 0, so I can isolate one variable. And the thing that's different about the previous video is I can't multiply one equation by some number to scale it up to match the other equation. Instead, I have to figure out, first of all, what variable do I want to cancel out? And then I have to multiply both equations to get that variable to be the same. In this case, I can try and get the x's to be the same. I could get them to be 15 because 5 and 3 both go into 15 evenly. But I'm going to try and get the y's to be the same number because then I can add a positive y to a negative y and then just very easily cancel it out. So I got to think to myself, what number does 4 and 9 both go into? And that number would be 36. And by the way, the easiest way to figure that out is to multiply them together. Unless one number, of course, is a multiple of the other number. But in this case, 4 and 9, the smallest number they can both fit into is 36. So in order to do this elimination magic, you got to kind of break out each equation separately. So I have 5x plus 4y is equal to negative 30. So again, I want to make the y's both 36. Oh, actually, I want to make one positive 36, one negative 36. Since this 4y is already positive, I'm going to make this one positive. So I got to multiply both sides by the same number. Property of equality keeps it equal. So what am I going to multiply 4 by to make 36? I'm going to multiply by 9. So I have to distribute this through 9 times 5 is going to be 45x, 9 times 5x. 9 times 4y is going to be 36y. And then, of course, I got to multiply this side. 9 times 3 is 27. So 9 times 30 is going to be 270. And then the negative sign, 9 times negative 30 will be negative 270. All right, so this is an equation I can use. Now let's go ahead and look at the other one. So here I have 3x minus 9y is equal to negative 18. Okay, so again, I want to multiply this by something that's going to make my y negative 36, and that's going to be positive 4 here. I got to multiply this side by positive 4. So I have 4 times 3 is going to be 12x, minus 4 times 9 is 36y, and then I got to multiply 4 by negative 18, so 4 times 10 is going to be 40, 4 times 8 is going to be 32, so 40 plus 32 is negative 72, negative 72 here, and it's negative because I'm multiplying the positive 4 by the negative 18 here. So this equation will also work for us. So I have to put them together as two scaled up versions. Again, they're the same equations as the original problem, but I want to make sure that they get set up together so that I can use addition to solve. So I'm going to go to a fresh slide. I got 45x plus 36y is equal to negative 270. And then below that I have 12x minus 36y is equal to negative 72. All right, so because I have positive 36y and negative 36y, I can add this. So 45x plus 12x is going to be, the x's here, 5, 6, 7, 4, 5, 57x. And this is going to become 0 equals negative 270 plus negative 72. So that's going to be 342. And so now I have 57x equals 342. So I got to solve for x here. All right, so if I divide this side by 57, and divide this side by 57, this is a hard one to do in your head, so maybe grab a calculator. This is going to be 6. So I have x equals 6 here. And so I'm going to try and just see if I can solve for y on this slide. So if x is 6, I just got to plug it back into one of the equations. I'm going to use the top one because it's positive and positive. So, but the bottom one will definitely work here too. So I have 5 times, instead of x, I'm going to put 6 plus 4y is equal to negative 30. Sorry for the stylus, it's kind of hard to write. 30 plus 4y is equal to negative 30. Subtract 30 here, subtract 30 here. I have 4y is equal to negative 60, and then 4 divided on both sides, y is going to be negative 15. So my answers are going to be 6 and negative 15. I do not have room for this, but if you wanted to make sure that that was your correct answer, you could plug both 6 and negative 15 into x and y in both equations, and if they were both true, then you would know that you were correct. Let's try another example. All right, so again, I can't add or subtract these equations together to eliminate a variable unless I scale one of them or both of them up. So you'll notice that these are positive, 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 positive equations here. And so because of that, I can't add, I'm going to have to subtract. So I can figure out what number does 5 and 3 go into, or what number does 4 and 6 go into. Either way, I'm just going to pick 5 and 3 because I know easily it's 15. So I'm going to go ahead and first scale this one up. I got 5x plus 4y is equal to negative 14. So I'm going to multiply both sides by 3. Both sides by 3 here, and I got 15x plus 3 times 4 is 12y, and it equals negative 14 times 3. So 3 times 10 is 30, 3 times 4 is 12, so it's going to be 42, and negative 42. All right, that's my first usable equation, and then I'm going to scale up this second one here. I got 3x plus 6y is equal to 6, and again, I want to make both x is 15, so I got to multiply this by 5 here, multiply this by 5. Let's change color. So 5 times 3x is going to be 15x, plus 5 times 6y is going to be 30y, and then 6 times 5 is 30. All right, so I'm going to move to the next slide, and then I will show you how to solve this. All right, so on the last slide we had 15x scaled up plus 12y is equal to negative 42, and then on the other equation we had 15x plus 30y is equal to positive 30. So in order to eliminate the x's, I have to subtract here. So I'm going to subtract. 15x minus 15x becomes 0. 12 minus 30. What's the difference between 30 and 12? So if I were to subtract 12 from 30, I would get 30 minus 10, which is 20, minus 2 is 18. So the difference is going to be 12 minus 30 is going to be negative 18. Y here. Okay, negative 42 minus 30, that means we're adding them, and that is going to be 4, 5, 6, 7, negative 72. All right, now we just have to solve for y. All right, so the way we get y alone is we divide both sides by negative 18. Negative 18 here, so this becomes y. Negative 72 divided by negative 18 is going to be positive 4, so y is 4. Now we just got to plug that back in to get x. I'm going to go ahead and, again, I just like the ones that don't have any negative signs. It's easier for me to do in my head. I got 3x plus 6, but instead of y, I'm going to put 4. Can you guys hear my daughter? I'm downstairs in my basement, and she is definitely jumping. Probably some Peppa Pig upstairs, and it's so loud. I'm not sure if you can hear it on the microphone or not. All right, so I got 3x plus 6 times 4 is going to be 24 equals 6. Subtract 24, subtract 24. I got 3x is equal to negative 18. Ooh, I'm running out of room. Divide by 3, divide by 3. X is going to be negative 6. So my answer should be negative 6, comma, positive 4. And again, you can check my answers by plugging them back into x and y to make sure both equations are true if those are the numbers substituted in. All right, thanks for watching this video. I know it's a lot, but you guys are going to be really good at this once you get some practice.